The line spectrum observed in case of hydrogen atoms, it can be explained quantitatively by Bohr's model. We know that Bohr's theory has 4 assumptions. Out of that, the second assumption, or assumption number 2, where it is written that the radiation or energy will be absorbed when the electrons move from the smaller principal quantum number to the orbit of higher principal quantum number. Suppose smaller quantum number n is equal to 1 and higher quantum number n is equal to 2. And when the radiation or energy will be emitted, that means that when the electron moves from the higher orbit, that means if you consider it 2 to the lower orbit when the n is equal to 1, principal quantum number. So in this case, the energy gap delta E will be denoted by the EF minus EI. That EF for the final state and EI is for the initial state. And so we have one equation, delta E is equal to EF minus E1. And from the previous class, we know that the energy of electron in stationary state, what is this? En is equal to minus RH multiplied by 1 by n square. But the small n is equal to 1 or 2 or 3. This one we discussed in the previous class. So if you consider this is the equation number 2, then if you combine this equation number 1 and equation number 2, E is equal to RH whole multiplied by 1 by n I square minus 1 by n F square. So ultimately this RH value, this is the Rydberg constant for hydrogen, and this value is fixed, 2.18 multiplied by 10 to the minus 18 joule. If we consider this equation, then we know the frequency. What is the frequency? Frequency rho is equal to delta E by H. That means delta E, if you replace with this value, this equation, then we'll find that frequency is equal to RH by H whole multiplied by 1 by Ni square minus 1 by Nf square. So now if we put the value, here you see Planck constant, small h is Planck constant, its value is there 6.626 multiplied by 10 to the minus 34 joule second. And above the delta E, we already found in this case, because it is the, if it is in the first case, then this part is the 2.18 multiplied 10 to minus 18 J. So this part is here, and in the whole bracket 1 by Ni square minus 1 by Nf square. So ultimately, if you calculate this first part, this value will be the 3.29 multiplied by 10 to the 15 and whole multiplied by 1 by Ni square minus 1 by Nf square, and then unit will be the hertz. That means you see that joule and joule it will cross, and then per second, and it will be called as hertz. So if we consider in respect of wave number, again wave number, what is the wave number? Rho bar is equal to the frequency divided by the speed of the light. So if you simplify this one, because the thing is that frequency already this value is there, so in that respect this value will come, second part this one, and first part RH by HC. This RH by H, this is the frequency in the first part multiplied by the 1 by Ni square minus 1 by Nf square, and C is divided. So in this case, if you put the value, that means you see that in above whatever I calculated is there, already this value is there, and speed of the light 3 multiplied by 10 to the power 8 meter per second, and second part is multiplied by the 1 by Ni square minus 1 by Nf square. So ultimately, if you simplify this first part, then the final result will be 1.09677 multiplied by 10 to the 7 and whole multiplied by 1 by Ni square minus 1 by Nf square. And in that case, the unit is the m to the power minus 1. That means meter to the power minus 1. We understood from this equation. When the Nf is greater than Ni, that means when Nf is greater than Ni, in that case, the delta E is positive. And in this case, the energy is absorbed. If you see that this is the greater and this is the initial. So if 1 by any less value, it will convert to the more value, and minus 1 by more value. Suppose consider the, suppose example 1 by 2 square minus 1 by 3 square. So this part, what will be this? Because this is the 4, 1 by 4 minus 1 by 9. So in this case, 36, 9 minus 4, that means 5 minus divided by 36. So this is the positive value. That means in this case, energy also will be the positive. But for the emission case, where the Ni is greater than Nf, that means the electron coming from above to down. So initial is above, that means Ni is greater and Nf is the less. That means if you consider from the N2, from N2, the electron is coming is equal to N1 state. In that case, if you calculate this, it will be reversed. In this case, the delta E is negative. That means energy is emitted or energy, we can tell it is released. So, in each case, one spectral line will be observed. So for this spectral line, each spectral line, whether in absorption and emission spectrum, both cases we can consider. Absorption spectrum, when the electron will go lower level to higher level, and emission spectrum, when the electron will come from higher level to lower level. In both cases, spectrum will be formed. And this spectral line can be associated to the particular transition in hydrogen atom. So, in case of a large number of hydrogen atoms, then different possible transition can be observed, and thus leading to a large number of spectral lines. Because if large number of hydrogen atoms is there, then it will absorb or emission with different energy. So large number of spectral line is possible. The brightness or intensity of the spectral line depends upon the number of the photons of the same wavelength or frequency, same frequency absorbed or emitted. That means the brightness or intensity of the spectral line, it depends on the two things. One is the number of photons, and these photons will have the same wavelength and or same frequency in case of both, whether it is absorbed or emitted. Calculate some problem. One problem is that what is the frequency and wavelength of a photon emitted during transition from n is equal to 5 state to n is equal to 2 state. Just my previous slide, I calculated this. So we'll take the help of this equation. Delta E is equal to 1.18 multiplied by 10 to the minus 18 joule in third bracket 1 by. So this is the initial state, because this will form the emission spectra. So initial state Ni in place of Ni, n is equal to 5, so 5 square minus, in the final state n is equal to 2, so minus 1 by 2 square. And then after calculation, final result will be 4.58 multiplied by 10 to the power minus 19 joule. And symbol, you can see this is the negative. That means delta E is negative. So delta E is negative. What does it mean? That it is an emission energy. So now we can calculate the frequency of the photon very easily, because the frequency we know that delta E by Planck constant H. So delta E now we know it is a 4.58 multiplied by 10 to the power minus 19 joule, and Planck constant is constant. We have to remember always 6.626 multiplied by 10 to the power minus 34 joule second. So ultimate this value, if you calculate and joule you cross, then second inverse, and second inverse it is called here the hertz. Now to find the lambda, that means wavelength. Wavelength, again we know that velocity of the light divided by the frequency. So now we know the frequency here, and C always constant, 3.0 multiplied by 10 to the power 8 meters second inverse, and divided by the frequency. In this case, we calculated just now. What is the value? 6.91 multiplied by 10 to the 14 hertz. Hertz is nothing but the second inverse. So second inverse will cut, and then ultimately meter will come, and when you convert to a nanometer, then this value you have to multiply with the 10 to the power 9 from meter to nanometer, then ultimately value will come 434 nanometer. So one thing we have to remember, that when from meter to you have to convert to the nanometer, then 10 to the power 9 nanometer. So this part you have to multiply here to get this value. Calculate the energy associated with the first orbit of He plus. He plus is ideally, it is like hydrogen atom, because He plus also have single electron, and hydrogen atom also has the single electron. So what is the radius of this orbit? So we'll take the first equation. We have to remember it. En is equal to 2.18 multiplied by 10 to the power minus 18 joule Z square by N square. Atom inverse, that means per atom. For He plus N, what is the N value? Because it has only one principal quantum number, so n is equal to 1. But Z atomic number, capital Z is denoted by the capital atomic number, and then atomic number of helium is 2. So now we can put this value here. Then E1, n is equal to 1, so E1 is equal to, in the same equation you have to replace the Z value with 2, and n, here n is equal to 1, you put the n is equal to 1 here, and the final calculation, minus 8.72 multiplied by 10 to the power minus 18 joule. And the radius of the orbit is given by the equation. In book this number is there. So we know, if you find the book and or my previous class, then you will find the radius. Radius is the Rn is equal to here the 0.0529 nanometer n square by Z. This is considered as A0. You can find my previous class. And then here n and Z both we know, n is equal to 1 and Z is equal to 2. Then Rn is the final value, will be 0.02645 nanometer.